Welcome to Statistical Computing with me, Erik Erhardt, Professor of Statistics at the University of New Mexico. In this video, we'll get started with R and LaTeX and learn some of the basic syntax and computing skills in R. So here we are at the course website. I'm going to scroll on down, and this video is posted under the first week where we're talking a little bit about reproducible research within the LaTeX R knitter environment, and the slides are at these links here. So I'll pop over to the slides. This lecture has a few parts. There's a short introduction about me and the course. There's a longer session about R and the syntax and operations within R, and then there's a little bit of detail at the end about LaTeX. But I think we're largely going to learn LaTeX by using it rather than through a lecture. So here we go. Welcome to the class. I'm really excited about this semester, and I hope you are too. Please call me Erik. I think Professor Erhardt is too formal for me. About me, I've got two great cats whom I adore. They're named after Marx Brothers. In my dissertation, I developed software and statistical models for understanding food webs in the environment, and I still do work in that area. As a postdoc, I worked with brain imaging data, developing models to help us understand what parts of the brain work together and what parts don't, and how that differs between patient populations. And I worked with a very talented researcher, Elena Allen, to make fantastic visualizations, and we were extremely productive together. I used to ride Mountain Unicycle and other unicycles all over. This is me descending Mount Monadnock in New Hampshire. I was the first person to do that. And these days I spend most of my time, free time, organizing dance and calling and teaching young leaders within contra dance and the community. Here we are. This is our building at the University of New Mexico. And I'm a professor here, and sometimes I'm a director of the Stat Consulting Clinic, and help out in lots of other ways. So the syllabus is online. You can take a look at the URL there. And we need a few tools for this class. You need some sort of computer. The software we're going to use are LaTeX for typesetting, R for computation, and we're going to use RStudio, which is going to help us put it all together. And you'll need your brain. You'll need the qualities of skepticism, curiosity, and organization to be a clear thinker and do good statistics. And you'll need good planning, execution, and clarity for writing good code that works and that other people can understand. Have a look at the syllabus online. I want to give you some empathy. Statistics can be challenging, and often I think people think it's going to be much easier than taking calculus or some other math class. And it's because we operate at high levels on Bloom's taxonomy. So this inverted pyramid on the right shows sort of where we are. If you're asked just to remember something, that's pretty basic. I can remember something you said a minute ago and say it back without even understanding what it was. To understand it takes more work, and to be able to apply what I understand is even harder. Our challenge in statistics is we are often operating at the analyze, evaluate, and create strata of this, which requires everything else below it. So, for example, doing a t-test requires us to divide two numbers and take a square root. But to understand the philosophical principles about why that's a sensible thing to do, that's a harder problem. All right, so we're going to work on getting up to speed with reproducible research. I've shown you in class already that how to use LaTeX, R, and knitter, and we've got, you can take a look at the reproducible links here on the R project CRAN page. The goal is to tie specific instructions to data analysis and experimental data so that scholarship can be recreated, better understood, and verified. Right? If you've ever done computations within an Excel spreadsheet or an OpenOffice spreadsheet, other spreadsheet programs are available, you know that all the computations are hidden. You've got to go to a cell, look at the formula, and look at the value that's represented in the cell, and then track down where that formula is pulling values from. And it's very easy to make mistakes, and famous mistakes have been made, ones that have affected, I think, even the United Nations budgets. So let's take a look at RStudio. This is going to be our primary environment here. You've already installed LaTeX R and RStudio on your computer, so this is what it looks like. We've got 4 windows in RStudio, and we'll cover each of these. I've changed my background to black because it's a little easier for my eyes, and I've also in RStudio I've moved the help window up into this upper tab. You can move these tabs around on the right hand side. So in the top left is the program editor. I recommend you write your code up there, and as you have lines that you want to, or commands you want to execute, you can either click Run or you can press Control-Enter and submit those lines from your editor window down into the console where all the action takes place. So execute code down here in the console. Up in the upper right hand window we've got a workspace and history. Your workspace tells you what variables are in your memory, and you can inspect what those values are up there if you want. I tend to do everything from the console, but you can also get that information in the workspace tab. And the history tab gives you the commands you've submitted. So if you did something really smart 15 commands ago, you can go to the history and page up and find it. For example, all I've done here is ask for help, $help. So there's only that one line there. And when I did $help, in the help window at the bottom, it's given me help and documentation about the help command. That's down here. There's a plotting tab here as well. In the other 2 tabs, we've got files on the left, which says which directory you are in, or which folder you're in, and the files that are listed there. And then packages are the packages you have installed on your computer and whether or not they have been loaded and can be run. I strongly recommend learning keyboard shortcuts. It will make your program faster and make your life more wonderful. Okay? A couple of the primary ones that I think you really need to know is pressing the Control key and the numbers 1 through 9 will take you to different tabs. For example, Control 1 goes to the first window up here, Control 1, the program editor window. Control 2 goes to the console. And then I think it's Control 3 and 4 for workspace and history, and then 5, 6, 7, 8 for files to help. And I guess probably Control 9 doesn't do anything, but you can try it. Control L clears the console. What else we have? There must be a Control Enter somewhere. It's probably down a little bit lower under Source. So you can go to the Help menu and find the keyboard shortcuts there. And I recommend learning a few. Maybe try to learn 1 or 2 new shortcuts every day and try to use those new shortcuts. All right, so here's our introduction to R. Ever feel like that? I hope I can keep this from happening and instead have you feel success, possibly diabolical success. I encourage you to work in teams. It's more fun, and you will be able to get each other unstuck when you get stuck. And everyone gets stuck very frequently. All right, R building blocks. So you can use R as a calculator. For example, what we'll see in these pages is you'll see a commented line that begins with a pound sign and some comment about what I'm trying to do. Then the next line will be a line of code. For example, here we've got 2 times 10. And if we put that into the console and press Enter, it will calculate it and return the result. The way it is printed out here, any results are on a black line with double pound sign to begin the line. The 1 in brackets indicates that the first value on that line is the first value in a vector of some length. And so in this case, it's the first value in a vector of length 1, and that's the number 20. That index in square brackets, the 1, only really comes into play when you've got long strings of numbers. Let me just show you very briefly what that's like. Here we are in the console window. I'm going to press Control L, and that will clear the console. Control L. All right. So let's look at a string of numbers. How about the numbers 1 to 100? Now we can see these indexes at the front of the line indicating something useful. We have a vector of length 100. It's actually a list of length 100. And the first one starts at index number 1. The second line, the 24 here, means that the next value is the 24th value in that list. Okay? 70 indicates the 70th value. So that's why there's always a little 1 here, because it's a very general report. Okay? So 2 times 10 is 20, 1 plus 2 is 3, does the things you expect. Orders of operations, 1 plus 5 times 10, okay? 5 times 10 is 50, plus 1 is 51. If you put parentheses, it's going to do the right thing. 1 plus 5 is 6, times 10 is 60. Exponents use the caret symbol, the shift 6 symbol. So 2 to the 5th power is 32, and 4 to the 1/2 power is 2. That's the square root. Vectors. So you can combine numbers into a vector, and this letter C is a function. It takes arguments such as 1, 4, 6, and 7, and it will combine them together to make a single list of numbers. So here we've got 1, 4, 6, 7 is a list of 4 numbers. You can use a colon to indicate, as I just did in RStudio, that you want a consecutive set of numbers. So 1:5 gives us the number 1, 2, 3, 4, 5, and then we're combining that list with the number 10. Sequence is another way of giving us a sequence of numbers, and it's a little more flexible. You can get a sequence from 1 to 10 by 2. What that does is it starts with the first number, and then it increments by 2. So we get 1, 3, 5, 7, 9, and the next increment would have got us to 11, which is greater than 10, therefore it's not printed. Another way to use this is to ask for a list of a certain length. Start at 0 and go to 50 and give me 11 numbers. Okay? Because I thought ahead, those 11 numbers are in increments of 5. That's nice. What will commonly happen is you'll ask for something like this. 1 to 50, give me 11 numbers, and then you get these fractional numbers. Not a big deal. May just not have been what you were expecting. Okay, so R also knows how to count backwards. 5:1 gives us the numbers 5 down to 1. We can assign anything to a variable. So here I'm assigning the list 1 through 5 to the letter A, and if you press A and enter at the console, it will return the value of A. Let's let B be the sequence 15 to 3, length 5. Okay, so it starts at 15, and it gives us a vector down to 3 with length 5. Now if you ask for A times B, it's going to do element-wise multiplication. So A is up here, it's the 1 through 5, B is here, 15 down to 3, and we're going to multiply each element at a time. So 1 times 15 is 15. 2 times 12 is 24, and so on. The last one being 5 times 3 is 15. Okay, so that's element-wise multiplication. That's the default. This is different than MATLAB. If you use MATLAB, the default is to do matrix multiplication, and you need to put a dot star in order to do element-wise. In R, the default is element-wise, and you need to do something special in order to make it matrix multiplication. All right, so here's some basic functions you'll want to know about. Here's A, that vector from 1 to 5. We can take the sum of those numbers, the product of those numbers, the mean, the standard deviation, the variance, the minimum, the maximum, the median, the maximum, and the range, which fell off the screen. The range is actually going to give you the minimum and the maximum value. So let me just show you that. If you do the range of the numbers 1 through 5, it gives you those extremes. All right, we'll go back. And there's tons of other functions built into R. Extracting subsets is an important skill. So let's start off with a vector A, or a list A, which goes from 0 to 10 by 10. So here it is, 0, 10, 20, all the way up to 100. Great. Square brackets are used in R to specify indices of an object. This is different from MATLAB, if you're familiar with that. MATLAB uses parentheses for everything, but R makes a distinction between parentheses and square brackets. So here, if you put A with empty square brackets, it's going to return everything to you. Okay? Here's A with only the 5th element. Okay, so that 5 is the index, it's the position. So what's the 5th value of A? Let's count. 0, 10, 20, 30, 40 is the 5th position, and that's the value that was returned. You can ask for a series of indices. So here I'm combining and making a list here, 2, 4, 6, 8, and it's going to return the 2nd, 4th, 8th, and 10th. 2nd, 4th, 6th, and 8th value. Okay, so that's the 10th, 30th, 50th, and 70. Okay, there they are. If you ask for the 0th index, R starts its indexing at 1, not at 0, the way C and some other programming languages do. So it says numeric 0, which is effectively like an empty set. Okay, there's nothing to return. The minus sign for indices indicates negation, meaning we want everything except these elements. So the 2nd, 4th, 6th, and 8th elements we're going to exclude because the minus sign is there. So it gave us everything else. You can have subsets that repeat indices. So here I'm going to pull the first, then the 6th, 6th, and 9th elements. So we get 0, 0, 0, 50, 50, and 80. And we can update a subset. I apologize for this thing that keeps popping up. Either we get the border up top or we get it in the screen. So here we've got, we're going to create a list with the numbers 333 and 555, and we're going to assign those two values to the first two positions of the list A. So when we ask for list A now, it's a little hard to see, but you can see the first element here is 333, the second is 555, and then it continues 20, 30, 40, and so on. Okay, so we've updated those two elements. I want you to become really familiar with this stuff. So I recommend as you're working, as you're listening to this lecture, be typing this into R and pressing pause when you need to and experiment and see what happens. Just try things and interact with the console. Let it be a conversation between you and the computer. All right, let's talk about Boolean operations. Boolean operation is something that operates with truth statements, something that returns true and false. Okay, so here's our new A. Here's our A vector. Remember, we updated those first two values, 333 and 555. If you wrap something in parentheses and don't have a function operating on that, okay, so you don't have a word before that parenthesis, then it's going to if you have a logical statement inside, it's going to evaluate that statement. So here we're asking the vector A, which values are greater than 50? So let's take a look. 333 is true. That's greater than 50. 555 is true. 20, 30, and 40 and 50 are all false because those are not greater than 50. And then 60 to the end are all true. Then we can combine these statements. So for example, we can ask which elements of A are greater than 50, and then we've wrapped that with square brackets to index it, and then we're going to return those values. So effectively, everything that's true will be returned. So 333 and 555 were true. There they are. 20 through 50 were all false. Those do not appear. And then we get 60 through 100. Exclamation point negates trues and falses. So this is the same statement that we had up here, and you can see all the trues and falses have been flipped. Okay. And so here we're asking, return to me the values of A that are not greater than 50. Perfect. That's what I wanted. There's lots of these comparison functions. We were just looking at the greater than. We have equal, and in order to assess the logical statement of equal, we need a double equal sign. So which value, return the value of A that's equal to 50. Okay. Here's return the value of A that's equal to 55. Now this would be think about, actually I want to break this down a little bit because it's important for me to understand, or for you to be thinking about this in a nice way. So I'm going to change my cursor. Sometimes copying and pasting doesn't work very well from a PDF, but we'll give it a shot. My computer sometimes tells me that there's an error even though there wasn't a functional error. So I'm going to clear my console and I'm going to create a vector A. Alright, there's my A. I'm going to go back and I'm going to do that replacement for those first two values. That's this line down here. Alright, so there's my A vector. Now, let me go to the next page. Two pages in. And I want to break this down. And the way I would write this code is I would start with, okay, say I want to write that statement. I probably wouldn't write that statement directly. Instead, I would probably write which value of A equals 50. That gives us a list of trues and falses. Okay? One of them is true. Now that I understand that I've got the correct logical statement, then I can press the up arrow. Up arrows recall statements. Okay, so you can press up and down to recall statements from the stack. And then I would wrap that with a bracket. So now I'm going to return that value, the one that said true. Oops, the one that said true. Okay, so when you start building these complicated combinations of expressions, you want to work from the inside out and make sure you understand each of those steps. All right, so for example, for this statement, which returned numeric 0, which means that there were no values, what was that inner expression? If I press enter here, I know that there's no values of A that are equal to 55. So it's a string of all falses. Therefore, nothing is returned. All right. Not equals is exclamation point equals. That's one way of specifying not equals. We've seen greater than before. Here's less than. And of course, you can do less than or greater than, and so on. There's also another function called in. And if I don't have it on the next slide, I will demonstrate that right now. Say we've got two lists. Okay, let's just make two lists, say the numbers 1, 2, 3, and 4. And we want to ask which of those values are in this list 3, 4, 5, 6. Okay, if I press enter, this false, false, true, true corresponds to this list here in each of those positions. So it first asks, is the number 1 in this list 3, 4, 5, 6? It's not, so that's false. Then it asks, how about the number 2? Is that in this list? False. Okay? 3 is in that list, therefore it's true, and 4 is in the list, therefore that's true. So if you want to compare lists, the operator %in percentage is the way to do that. And there's a few reserve functions that are words within parentheses. All right. Boolean operators. So we've seen true and false statements, but now we want to operate on those true and false statements. So we can do an AND statement with the ampersand. We can do an OR statement with the pipe. The pipe is the shift key above the enter key. It's a shift backslash. It's the vertical bar is called a pipe. And exclamation point is not. It negates true and false. We've seen that already. So here's a statement that looks pretty complicated. And the way to approach this is to, I've just copied the statement, is to break it down into each of the parts. Okay? So there's actually 4 things going on in this statement, and we'll look at each one just now. The first one is, let me make a couple extra lines. Which values of A are greater than or equal to 50? Okay, so this is the list up here, the A list that we're using. So you should be able to predict the list of trues and falses. I'm going to predict true for 3 through 3, true for 5 for 5. Then we've got false, false, false for 20, 30, 40. And then 50, it starts to be true again, and the rest of them. So if I press enter and mean it, there we go. So we got true, true, false, 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 and the rest are true. Great. Then I have the expression which values of A are less than or equal to 90. Okay, and you can go through the same situation. The first 2 are large numbers, they're false. Then we have a bunch of trues until we get up to 90. Oh, sorry, the last one, only the last one is false. 100. Okay, good. Then we have this ampersand, which is asking for these 2 lists of true and falses, which ones are both true. So we have a true false, so that first element should be false. True false, that's false. False true is false, only when they're both true. And that starts here. So those 5 should be the ones that are true when I press enter. Let's see. All right, good. I'm thinking like a computer. And that's what's really required to become a good programmer, to think about what the computer, how the computer interprets these expressions. Finally, these are the values that I want to return from A. Those are the indices that I want. So which values are those? Those are the values, should be, well, we already saw it down here, 50 through 90. All right, so we got what we wanted. So that's how to think through these problems. Start from the inside, examine each element or inspect each element and see how they combine and build up an expression to meet your needs. Okay, so the same thing can happen here. So I recommend doing that for each of these statements as well. Okay, we've got an OR, and we have the negation. All right, missing values. Missing values can occur for lots of reasons, and they are represented by NA, which means not available. And any calculation involving an NA is going to return NA by default, right? If a number is missing and you try to add 5, or in this case add 8 to that missing number, what's the result? You don't know. You only know that it's 8 more than what it was before, or what it wasn't. Okay? So here we've added, here we've multiplied. Here we're taking the mean, and you're trying to calculate, you're adding and then dividing, so that becomes an NA. Many functions have an argument that says what to do with NAs. So what should I do with this NA? We should remove it. And here that is specified as true. Let me go over to R for a moment. And I'm going to clear the console and ask for help for the mean by typing $mean. In the help window to the right, we'll get the help for this. And the help window starts off by telling you the function name is mean. The package is the base package. It gives the title of the function. This is the arithmetic mean, and a short description. It's going to be able to calculate a trimmed arithmetic mean. The usage is you type mean and you put the number in there, and the ... indicates that more arguments can follow. In the default, when you use the mean function, it says trim equals 0, and these arguments are defined below. And then na.rm. Do you want to remove missing values before you do the calculation? The default is false. So if there's any NAs in there, by default it will return an NA. So in order to change the behavior, I'll go back over here, I've had to specify true. And once you do, then we get a number, 1.5. Great. Same thing with sum. Sum has that same argument. All right, next slide. All right. Here's a way that you can remove missing values yourself if you want. There is a function called is.na. In fact, there's a whole bunch of is. Functions. Over here in the console, I'll type is. And I didn't even press anything. I just lifted my hands from the keyboard after I pressed dot, and it came up with lots of options. This is a sort of a newer option in RStudio. Alternatively, I could have pressed the tab key, though it appears that that auto replaces these days. So it asks, is the object you're about to inspect, is it an array? Is it a character vector? Is it a complex number? Is it a data frame? So if you're unsure about what the object is, there's all these options. Are the numbers finite? Okay. Do you have any infinites? And the one we're looking at right now is NA. So here's our new vector A. It's got some missing values in it. So if you type is NA, the object A, and press enter, it gives us trues and falses, and it tells us which ones are missing. So the first one is missing, and the last one is missing. Everything else is a number. It's not missing. So you can put an exclamation point in front of that, and that tells you which values are not missing. And so what I've done over here is I've returned the values that were not missing. And so I get the numbers 1 through 5. That's these guys. Pretty nice. One comment here. Here, take a look at what I'm doing. I have an object A, and I'm rewriting it. I'm overwriting the value A with a new version of itself. Okay? That is destructive. It's okay to do it, but know what you're doing and be careful. You started off with this vector initially, and now you've got this. You have no record anymore that you had missing values in there. Okay. All right, so here's a time to test your skills. We've got 3 questions, and I want you to press pause and work through on paper or just in your head. I recommend paper. And think like a computer and come up with this solution. So press pause and come back when you've got the answer. Okay, I'm coming back with my voice. I'm going to assume that you pressed pause, you worked it out, and got one of these answers. Let's take a look at what working this out looks like. On the next slide, x is 3 to 7. Okay, that gives me a vector 3, 4, 5, 6, 7. Now, the next expression was to add two subsets together. So let's take a look at those two subsets. The first two elements of x are 3 and 4. This command is specifying I want all the values of x except the first three values. Okay, so that's values 6 and 7. Now I'm going to add those together, and addition happens element-wise. So I get the number 3 plus 6 gives me 9. And then 4 plus 7 gives me 11. Finally, I'm going to take the product of y. Y is this list of numbers 9 and 11. 9 times 11, 99. So if you got it, good work. If you didn't get it, that's okay. It takes practice, and you'll get better at it. Let's take a look at the next question. So go ahead and press pause, and come back when you've got a result. All right, we're back. And so what value will R return for Z? All right, so we got to think about this now. Sequence from -3 up to 3 by 2. Let's take a look at the next slide. That starts at -3 and it increments by 2 until we get up to +3. So now we've got these four numbers. The next, we're going to assign a value a from x. So which values of x are greater than 0? That's 1 and 3. So it's going to return, a is going to be a vector, here we are, 1 and 3. B, what's the vector b? This is going to be the values of x that are less than 0. Okay, that returns -3 and -1. Now I'm going to take the difference of the first element of a, that's 1, minus the second element of b, that's a -1. So 1 minus a -1 is +2. All right, one more. All right, so we've got what value of R is going to return for Z. So we've got A, B, and D. It looks like we've got some logical statements and some Boolean expressions here. So go ahead and press pause and come back in a minute. All right, we're back. Let's take a look. There's a lot of steps here, so we've got to think through this carefully. A is going to start off with a list from 2 colon -3. So it's going to be 2. Let me go to the next slide. It's a little bit small. All right. So we start at 2 and go 1, 0, -1, all the way down to -3. All right, so we have a list of length 6. We ask A, which values of A are greater than 0, and return those. That's the numbers 2 and 1. And then we have which values of A are greater than or less than or equal to 0, 0 and below. Okay, so that's those. Finally, we ask, we're going to combine those together. So the vector B is going to be all the values that are greater than 0 and less than or equal to 0. Well, B happens to be empty. There's nothing, no values that are both greater than 0 and less than or equal to 0. Let me go back one slide just to remind us where we are. So B is empty. There's nothing in B. So basically it's going to come down to whatever's in D. So we have to figure out what values are identified by this first expression and the second expression and combine them. Sorry, pressing too many buttons. All right, so D is created in this way. So this first set of elements are which values of A are greater than 1, and then we negate that. So the values that are not greater than 1 are 1 and below. How about the values of a that are less than or equal to -1? Okay, so that's -1 down to -3. And I'm taking an ampersand to combine those two. So which values appear in both sets? -1, -2, -3. So D is that vector, -1, -2, -3. Finally, sorry about that, we're going to add them together to get -6. So those are fairly challenging exercises, but ones that I expect you to be able to do pretty soon, to be able to think like the computer. So how'd you do? Did you do outstanding? You're understanding the operations and how to put them together without skipping steps. That's really important, to think through every single step and not miss any part of it. You're doing good if you're understanding most of the small steps, but maybe missed a couple details. And I hope you'll hang in there if you're finding that these concepts and symbols are making your eyes spin. All right? Reading and writing in a new language takes work, and you'll get better with practice. And if you've got a buddy to work with, all the better. All right, so I hope it's going well. Maybe just a couple words about LaTeX. We're going to use LaTeX in this class to do typesetting. It is, for scientific documents, the de facto standard. It's, for my money, which is free, but it's sort of a priceless tool for me. It provides not only the most beautiful documents, but very easy documents to create and share. So we have instructions on the website for getting all that installed. And one set of comments here, this is actually an important setup point. Go into RStudio, go into the menu and options, and there's a sweeve option, and you want to turn that on to knitter. Okay? And so let me actually take you through that right now. Here in RStudio, I'm going to go to Tools, Global Options. There's a bunch of categories here. SWeave is here. And the default may have been SWeave. So make sure that's knitter. And secondly, at the bottom, there's a option here for concordance. If you find that you're having trouble, sometimes unchecking that will be helpful. Concordance is a way that allows you to get error messages with the correct corresponding line number with where the error took place. So it's a helpful tool, but in my experience, it doesn't always work quite as I would like. All right, and you've already today perhaps downloaded and used the student template. All right, learning LaTeX is going to take practice and becoming good at reading the log file to see what errors are created takes practice. Okay, if you happen to get errors as you're writing LaTeX, my recommend is just to take big chunks of code, or whether it's in R or in LaTeX, and just comment it, and then compile or run it again until you stop getting errors. Then you can start adding in code and see eventually which line created the offensive error. All right, so that brings us to the end of this discussion. Good work. Programming in a new language is a challenge, but we've got each other to work together in class, and there's lots of resources online. I will often type in to Google, in fact, let me do it right now, just an example, R, oh, here we go, ggplot remove legend. This is something that I needed to do recently, and you can just search for it, and there's so much help these days. You'll often find early in the search results something from Stack Overflow, and those are often very good answers. So, see you in class, and keep practicing.